Alright guys, today we're going to cover further statistics. This is set 28. Most of the examinable content for statistics have been already covered in chapter 9. This is just extra work, just so that you guys understand how all these things come together and give you a little bit of more advanced material. Most of these things that we cover in this video won't be examinable, but some might be, so it's better to just get an understanding of how statistics work and how all these things come together, so that when you're doing questions, you're more aware and you know what to look for. Okay? Let's look at relative frequency. To find out relative frequency of a score, what we do is get the frequency of a score and put it over the total frequency. Okay? So for example, have a look at the example here. We have a score of 5 and a frequency of 9. Okay, so score of 5, frequency of 9. What we need to do is add up the frequencies to get the total frequency. The total frequency will be 40, because here total F is equal to 40. 9 plus 14 plus 12 plus 5 gives us 40. And to find out the relative frequency of score 5, we just do 9 over 40. Okay, and that's it. And put this in the calculator to see if you want to get a decimal, but if not, we can just leave it as a fraction as 9 over 40. And that's it for relative frequency. If you want to have a look at the relative frequency for number 6, just do 14 over 40. For number 7, we do 12 over 40. And finally for 8, we do 5 over 40, which is 1 on 8. We can simplify these ones too, but I didn't. Okay. Also, another way of thinking about it is the frequency of 5, or the number of times that the score 5 has occurred, is 22.5%. Okay? Or the number of times that 6 has occurred is 35%. Or the number of times that 8 has occurred is 1 in 8. Okay, that's another way to look at it. And always, if you're doing relative frequencies for a table, add up the relative frequencies to see if it adds up to 100 or 1. Okay, if you're doing percentages, it needs to add up to 100%. If you're doing decimals, it just needs to add up to 1. Okay, and that's it for relative frequencies. Let's have a look at range. Range is something that will be examinable. And you've already talked about range in chapter 9 when we did the video for chapter 9. Okay, so with the range, what we do is we take the highest score and take away the lowest score. Okay, let's have a look at these sets of scores here. What's the highest score here? It will be 75, and the lowest one 0. So the range will be 75 minus 0, which gives us 75. Let's do Steve. What's the highest score here? It will be 90. And the lowest score, 20. So the range for Steve is 90 minus 20, which is 70. And that's it. And they've done mean as well. To do mean, what you need to do is add up all the scores divided by the number of times the scores have occurred. So 1, 2, 3, 4, 5, 6, 7, 8. That's what they've done. 408 divided by 8 gives us 51. Okay. And they've done the same for Steve. It's 408 divided by 8 gives us 51. So the means are the same and the range differs a little bit, but we still can't say who's more consistent. We can see who's more consistent by looking at the individual scores, but sometimes when you're dealing with a large number of sets or sets with a lot of scores, it's easy to just, not go through every single individual score to identify whether one is more consistent than the other. Okay, over here, we can go through the individual scores because there are only 8 scores here. And obviously tell that Mark is more consistent than Steve. Steve gets 20s and 30s, and all the big numbers like 90s and 80s are pretty much outliers. Whereas Mark always gets around 50s to 40s, 40s to 50s, and they're always in that range. This is just the outlier, 0. So we can tell that Mark could be more consistent. Okay? But we'll now have a look at a different way of looking at consistency. This is standard deviation. So standard deviation looks at how widespread the scores are. Okay, so for example, we look at how far away the scores are from the mean, which is the average, and how dispersed they are. So we're looking at the dispersion of the scores from the mean. And to find that, this is the formula that we use: the square root of the total of the mean minus each score squared. Okay, then you divide it all by the number of scores. This is a very tedious and long method. That's why we don't recommend doing it by hand and using a calculator when you're doing these type of questions. Okay, and when you're using this formula, what you need to do is you need to take the mean. We know that the mean is 51 for both cricketers, and minus 51 from each score. So the first score was 42, and then square it. And then you do it for the second one, 51 minus 56, and then square it. Okay, this should all give you positive values, and you do it for all 8 numbers. You divide it by 8, and then you square root it. Okay, and that's how you get the standard deviation. They've given us the standard deviation for Mark to be 21.9 and Steve to be 28. The higher the standard deviation, the more widespread the scores are. The more widespread the scores are, the more inconsistent a player is. So since Steve has the higher standard deviation and his scores are the more widespread scores, he's the more inconsistent player. So the more consistent player will be Mark. Okay? So Mark is a more consistent batsman than Steve. And that's how we do that. And this is another way to do it. You can put it in the calculator. There is a mode that you can use on the calculator that's called the SD mode, where you plug in the mean and give the set of scores, and then you press the standard deviation button. Okay, and it just spits out the standard deviation for you. If we have a look at these two ones, we can't really tell by just looking at it who's more consistent. And both the scores have a similar mean. For maths it's 66.3, and for science it's 62.8. But for science, the standard deviation is much higher. And that's why he's performed much better in maths than science. Okay? Now, let's look at the normal curve. Normal curve is also known as a bell curve. You might have heard of it. When you're doing exams and stuff like that, especially the selective high school exam, what they do is they collect all scores together and put them in a bell curve. So those who do the very best, they'll be here in the top 0.3%. Those who do those who do the poorest will be in here in the top 99.7%, or the bottom 0.3%. Okay, bottom, top. Okay, and this is where most of the scores are, which is 68% of the scores. Okay. And after 2 standard deviations, it'll be 95% of the scores, and after 3 standard deviations, it'll be 99.7% of the scores. Okay, just read through this box here and you'll understand what it means. Okay, so they're saying, let's use a highlighter. 68% of the scores lie within one standard deviation of the mean. So this is half a standard deviation and this is one standard deviation. Okay, and now they're saying 95% of the scores lie within two standard deviations. So this is half, then one. So altogether, this is 95% of the scores. Okay, now let's have a look at this one. Oh, whoops. Let's get the eraser. 3 standard deviations. 99.7% of all the scores lie between 3 standard deviations. So this one. So altogether, blue, green, and yellow consist of 99.7% of all the scores. Okay, and that's why we look at the normal curve when we're looking at what the percentage of people are between a range. For example, if we have a look at the heights over here, they took 100 students from year 10 and they looked at the mean height and the standard deviation to be 6 centimeters. To find what percentage of people are between 164 and 176, what we do is we see what the mean is. Mean is 170. So how far away is 176 from the mean? It's 1 standard deviation, which is 6. How far away is 164 from the mean? It's also 6 centimeters, so one standard deviation, right? So we take this as half to be 2 standard deviations. So therefore, two halves of standard deviations make 1 standard deviation. So students between 164 and 176 make up 68% of the population, or 68 students, because there were 100 students who were measured. Now let's have a look at the second one. What percentage have a height between 158 and 182? To get to 182, you go 12 centimeters up. To get to 158, you go 12 centimeters down. So that's 2 standard deviations. And between these two numbers, how many students fall in that category? That'll be 95%, or 95 students. How many students are taller than 188? 188 gives us 18, 3 standard deviations to the right. But remember, it's taller than 188, so it's just this bit. And all of this before that bit will be 99.7%. So what's remaining? We just do 100 minus 99.7%, which gives us 0.3. But that 0.3 needs to be divided by 2, because there's also this other bit here that is also complementary to this bit over here. Okay, so we divide this by 2, which gives us 0.15%. And students who are taller than 188 centimeters will be 0.15%. So very unlikely that there are students taller than 188. Okay, that's it. Let's have a look at the questions. Let's start with this one. What is the frequency? What's the total frequency? So to find out the total frequency, we need to add all these up. Okay, so we do 2 plus 5 plus 7 plus 11 plus 8 plus 2. That gives us 35. Okay, and then we find out the frequency, the relative frequency for each score. To find the first one, we just do 2 over 35. Put that in the calculator. It should give us 0.06. Answer to 2 decimal places. Okay, so this one 0.06. Let's do the second one. 5 over 35. 0.14. 7 over 35. 0.20. An easier way to look at it is also 5 is 2 more than 7. We know that 2 is 0.06, so We just add these two together to give us 0.2. 11 is 4 more than 7. So we just do 0.2 plus 0.12, which gives us 0.32. Okay. Or we can just do 11 on 35 and see what you get and answer it to 2 decimal places. This one will be 0.18, I believe. Not quite. We're not quite sure. Just do 8 on 35, which should give us 0.23. And the last one is 2 again, 0.06. They should all add up to approximately 1. It won't always be 1 because we're rounding up or down, so it'll just be a little bit off every time we do it. Alrighty, let's go have a look at question 2a. You guys can do 1b by yourselves. It shouldn't be too hard, and the answers will be on the next page. We need to find the mean, range, and standard deviation for the following sets of scores. Now, how do we find the mean? We add them all up, divided by the number of scores. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we just add them all up, divided by 11. Let's do that. I got 18.16. Have a look and see if you guys get the same answer. Now let's have a look at the range. The range is biggest number minus the smallest number. Biggest number is 9. Smallest number is 2. 9 minus 2 gives us 7. Standard deviation, just put it in the calculator. I'll put it in my calculator. I got 1.17. Okay, just follow the formula for standard deviation. This is the symbol for standard deviation. The formula will be the total of mean minus each score squared divided by the number of scores. That's it. It's a very tedious task, but just do it for one question so that you guys know how to do it. Or you can just, instead of doing it manually like this, go in standard deviation mode on your calculator and do it there. Alright. I'll just do the mean and median and give you the standard deviation because it just takes a while. Alright. To find the mean, what we need to do is to do 16 times 4 and then add all the numbers up. 17 times 9 gives us 270? No, 153. 18 times 15 gives us 270. 19 times 10, 190. 20 times 7, 140. Add these all up and see what you get, and then add the frequencies up. 25 plus 7, 32, 32, 41, 41 plus 4, 45, okay? And divide everything by 45, okay? Add all these up, divide by 45. That should give us 5.7. Okay, now we're looking at the median. Median is which one is right in the middle. 45 divided by 2 gives us 22.5. And 22.5, which one is 22.54? Plus 9 gives us 11. 11 plus 15 gives us 11 plus 15 gives us 26. So we know that 22.5 is within the score of 18, so the median will be 18. Okay, and then do the standard deviation by yourselves. It's just easy. Just put the scores into this formula, and you should get for question 2 a standard deviation of 1.17. Okay, so question 3 should get 1.17. Here should be 2, not 1.17. Okay, it should be 2.0. It's to 1 decimal place. Alrighty, let's move on. Which of the test results, X, Y, Z, is the better compared to the results of the class? These are the type of questions you'll actually get in the exam, because these ones that we've done take a long time. They might ask you median and mean, but not standard deviation. So be careful of that. They'll probably ask you relative frequency and total frequency, but never standard deviation, unless it's like couple of things, like 4 scores of sets of scores. Okay, now let's have a look at this one. This one might definitely come on the exam. We have a result of 63 and the class average is 67. Has he done better than the average? No. So he's not going to be a candidate. Let's have a look at Y. The class average is 54 and the result is 58. Has he done better than the average? Yes, he has. For Z, the result is 74, class average is 78. Has he done better than the average? No. So we know that Y has performed the best compared to all these two. Let's have a look at this one. Result is 71, class average is 78. Have not done better than the average. 58 and 55 has done better than the average, so he might be in the running. 67 and 62 have done better than the average. And now we look at the standard deviation. The higher the standard deviation, the worse they've performed, better they've performed. Okay, so here they've performed better because there's a wide spread of results, and it's harder to achieve a good result. Okay, and have a look here. How much more from the average is he? 5. How much more is from the average is he? Only 3. Okay, so Z has definitely done better. So the answer is Z for this one, and Y and Z. Let's have a look at this one, last one. The mean birth weight of 100 babies was found to be 3.625 kilos with a standard deviation of 250 grams. The percentage of babies with a weight between 3.125 and 4.125. So we know that the mean, let's get rid of this, let's draw it again. Proper bell curve. It's better. Is 3.625. Right in the middle. They're asking us the babies between 3.125 and 4.125. That's 500 grams on each side. That's 2 standard deviations. 1 and 2. Okay. From the box before, what is 2 standard deviations equal to? 95%. So they're asking us how many babies are between these two weights. There will be 2 standard deviations, therefore 95%, which is 95 babies. Okay, easy. Next one. The percentage of babies with the weight between 3.625 and 3.875. 3.625 is right in the middle. Okay, that's the mean. Right in the middle. And 3.875 is 1 standard deviation to the right. Okay, we know that half a standard deviation actually, because this will be a full standard deviation. So we know that it's only this bit that we're looking at. So what's half of 1 standard deviation? We know that 1 standard deviation is 68%. Therefore, half of 1 standard deviation is 34%. So there are 34 babies between 3.625 and 3.875. Now, last one. The percentage of babies weighing less than 2.875. 2.875 is how many standard deviations? 3 standard deviations to the left. Okay, and it has to be less than the 3. Okay, so we know that 3 standard deviations is 99.7%, and less than 3 is 0.3%, because it's 1 minus 99.9, 100 minus 99.9, 99.7%. Okay, but we're only looking at those who are less than 2.875. We're not looking at this part. So since we're only looking at on the left hand side, we need to divide this by 2, which gives us 0.15%, and that's our answer. You guys can have a look at the answers over here. Don't look at the probability ones, just the questions from 1 to 5. Okay, and see which ones you got wrong and try them again. All right, and that's it for this video.